We request the dignitaries on the dais to take their seats among the audience because we have a distinguished lecture now. Now I request Dr. Michael Milligan, sir, to deliver the distinguished lecture on empowering tomorrow's innovations, cultivating curiosity and resilience in Gen AI era.
Okay, well, kind of actually picking up on what Bill Oakes said. Where's Bill? Here he is here. In engineering, we often think we know a lot more about technical solutions to complex problems than we really do. And curious minds often challenge these assumptions and seek the real truth, and won't settle for the tip of the iceberg, if you will. I think we have a unique opportunity to cultivate curiosity, and we've actually heard that a little bit even in the opening remarks this morning. And this is where real innovation happens. And I can tell you that now more than ever, we need innovation. About today is this idea of empowering tomorrow's innovators and cultivating curiosity and resilience. And now we are in this Gen AI era, right, with artificial intelligence. My name is Michael Milligan. I'm the ABET CEO. You've probably heard that already, and I'm pleased to be here. And I want to thank the program committee for inviting me. And I always look forward to the opportunity to come to India and address all of you. I think 2011 maybe was the first time I was here. So not as many times as Bill, but I've been here numerous times, and love the opportunity to be with you all again. What I'd wanted to do is talk about some big problems. And the first thing you'd ask is, well, what is the biggest problem? And of course, we have many that we need to address. But the one I wanted to focus on really is climate change, because I think that's an existential threat to all of us. And it's something that we are running out of time on in terms of solving. So I think we've all seen scenes like this, lots of destruction, natural disasters, and so forth. But I think the thing that's been most shocking is how quickly it's happened. I mean, even not that many years ago, scientists were predicting, significant changes to our environment and the consequences. But it's astounding how quickly this has all happened. And I think it only, supports this concept that we really do need to make some significant changes quickly. One of the things that we all know, I think, is that the Earth is warming, and it's warming pretty rapidly. And if you look at this chart here, this is data taken from the NOAA environmental satellites. You'll see that the North Pole specifically has been heating more than any of the others. And again, I don't think many of you would be surprised at this information, but the consequences are pretty dire. And I had an opportunity to fly back from Ireland to Newark, New York, and at that time there was a big storm over the North Atlantic, so they routed all the planes over much farther north than they would normally go, and so we went over Greenland. And these are pictures that I took with my iPhone. I actually have a long history of taking photographs with really nice cameras like this gentleman here, but the iPhone I find is extremely helpful, very timely and all that. But this is what we expect to see over Greenland, right? You see the ice, the snow. I think Eric the Red was the one who sold Greenland as being green to the Danes, but in fact it's not. But in any event, this is what you expect to see. But as we traveled further west, the landscape changed pretty significantly. And so this is a photograph that I took just a little bit later, and you can see the ice melt. And this is particularly significant because between Greenland and Antarctica, the ice sheets hold basically 2/3 of the world's fresh water. Okay, and they're both melting pretty rapidly. I think Greenland at 270 billion tons of the ice sheet every year, and Antarctica about 150 billion tons. So lots of ice melt. And so, but it's quite beautiful in a sense, because if you look at these, you can see the glaciers melting, they're retreating into the ocean, and you can see how that looks like just like a river of snow and ice, which is exactly what it is. And then this one I think is particularly beautiful. If you look at that, it's just kind of like this nice river, and then it sort of just melts away into the ocean. And so while it's quite beautiful, it's quite dangerous at the same time. And so something that certainly we need to address. I think everyone understands this idea of the global surface temperature rising, and it's basically since the 1940s onward when we really started to crank out a lot of emissions, carbon dioxide into the atmosphere. And when you look at this, you'll say, what's the big deal? It's 1 degree centigrade. That's what that scale says. It's 1 degree centigrade in warming. So what's the big deal? Can't we handle that? And in fact, the oceans themselves are huge heat sinks. I mean, tremendous heat sinks. So in order to actually raise the temperature by that much, 1 degree centigrade requires a tremendous amount of heat, right? Tremendous amount of heat, and it's changing all aspects of our environment. So if you look into the future, and we like to do that, and so NASA, thanks very much for supplying data to us. If you look at these scenarios, they're not really all that great. And so the vertical scale here is sea level rise, right? So we're talking about 2300, so that's a long ways away, right? But still, between now and then, a lot of thresholds will be crossed. But the thing that I think is most urgent is, you could look at the best case scenario, which is there in blue, the worst case there in red. And I think we've all witnessed the fact that, I don't know, as a species, we're not really doing enough. We're not doing enough, and we're not doing it fast enough to basically save ourselves. And so looking at that, if you just take the kind of the worst case, you'll see places like this in North America, Florida, which, so South Florida would be gone. And this is not unrealistic, right? They have sea level rise problems there now, but most of the coastlines will be gone all the way up the East Coast, and then in Asia as well. So takes us to this idea of what about artificial intelligence, and what can artificial intelligence do to help solve these problems? Well, the first thing that I think is important is it's going to be a tool that we can all use, right? It's going to accelerate the way that we can address these kind of problems, but it's not a silver bullet. And for those that aren't familiar with this term, silver bullet, basically what that refers to is a singular solution that we sort of get lucky in a sense that solves the problem, but it's not going to be that, okay? And we heard yesterday about artificial intelligence, and it's artificial, it's not real intelligence and all of that, but it certainly will help us. And this is where you can start engaging with students, okay? At ABET, we get the question all the time, what about artificial intelligence? What do you think about it? How does it affect the curriculum, right? Clearly, we need to engage students in this. The Boston Consulting Group, which is all focused on business, all right, did a study recently on AI and using it to help, predict, manage, so forth, our atmospheric conditions and so forth. And you can see the numbers that they put there. Like if you were to use multiple AI tools in very effective and efficient ways, we could reduce the output into the atmosphere up to 5.3 gigatons of carbon dioxide. And I've never seen a gigaton, but that sounds like a really big number, right? A lot of carbon dioxide that you won't be in the atmosphere. But more importantly, no, let me take that back. Not more importantly, but what would catch a lot of people's eyes is the dollar amount, right? Because again, this is about business, and business is going to drive many of the solutions and many of the consequences if we don't make the right choices. And when you see $1 trillion to $3 trillion of economic benefit, that gets people motivated, all right? So here's an example of how AI can help us. There are AI tools that are being used right now to track how quickly icebergs are melting and changing and all that. And using these tools, they can do that 10,000 times faster than humans. So it's a really good tool. It's not going to solve the problem, but it's going to help us, empower us to come up with better solutions. So that's a great thing. Deforestation, I think most of us know about deforestation. The forests that we have are great sinks of carbon dioxide. We need more of them. And unfortunately, in many areas, it's going in the other direction where they're being deforested. But AI can help us, because one of the challenges with reforestation is as our climate changes, species that once thrive in certain areas maybe won't thrive in those areas again. So we can use AI and remote sensing and so forth to help us plan out what's the best way to do that. And so I think that's another great way. Helping clean our oceans, I'm going to talk a little bit more about this in just a few minutes, but AI is a great tool to help us map areas of the oceans where, especially in the remote areas of the world, where we can go after some of this pollution that affects very broadly our ecosystem. Now, here's a chart here that I borrowed from one of my colleagues at MathWorks, Dr. Tanya Morton, and she presented at WEEF just a few months ago. And one of the things that she was addressing was AI and sustainability. But there's a flip side to this too, because as you can see, these electric demand growth projections, data centers is one of the big ones, right? So if we use more and more artificial intelligence and using the data centers in the cloud and all that is going to increase. Of course, you got the Bitcoin generators and all that, but nonetheless, it's still something that we need to keep our eye on. So if we're going to make a significant change, we have to pay attention to what we call this data center dilemma, which is really, we want to be able to use these high power computers and all the storage to help us solve these big problems, but at the same time, we're exacerbating the problem to a degree. So how do you balance that? Do we keep, we need to balance it and keep that in mind in any of the solutions. The good news in some ways, though, is the general public. And the general public is very fickle and goes with different trends and so forth. But fortunately, or unfortunately, most people think that tech is the answer. Okay, so high tech's going to solve all our problems. Well, I've spoken here before about a similar topic, and it always comes back to human behavior, because human behavior is the one that's hard to change, right? But nonetheless, having the general public trust the tech sector to help solve the problems is good, because it allows for funding, it allows us to try experimentation, it allows us to do a lot of things that maybe we wouldn't be able to do, especially with governments involved. So who can solve these problems? Well, one of the examples that I like to use, see if I can get this up, is Boyan Slat. So I put 2018 because I was at this conference in 2018. I used him as an example. And the reason I chose him was he was a former aerospace engineering student at Delft University in the Netherlands, and he went to Indonesia and with his partner to go scuba diving. And for those that have been to Indonesia, the waters are pristine, the marine life is amazing, but what he ended up seeing was a lot of this, okay? And he saw a lot of this. And so he thought about it and said, I need to fix this and clean this up, all right? And if you look at the scale of the problem, it's enormous, all right? It's almost one of those problems that seems it's too big to solve. Here's an example of the Great Pacific Garbage Patch, which is the largest of many garbage patches that are floating around in our oceans, and it's 3 times the size of France, so it's very large. And actually, these numbers are probably a bit old now, but you can see almost over 2 billion pieces of plastic, many microplastics, which you probably have read end up in the food chain and are in many of our own bodies and so forth. So it's a huge problem. But the reason I like to use this example is because he was someone that wasn't deterred by, hey, the problem is too big. This is the same thing we need to do with our students. These problems are not too big. We have to start somewhere, and we can solve them, right? These are the big, complex problems that are facing us but need to be solved, and we can't shy away from them because we think they're too challenging. It's a system of autonomous cleaners. Here's an early example of one of their prototypes. It uses high technology, the satellite navigation. They're, as I said, autonomous, so they kind of float around the oceans. They pick up a lot of plastic waste. They use a lot of low technology too, so they use not just the high tech sort of things that I was showing you, but also pipes and booms and skirts to kind of grab all this plastic, allow the marine life to get through. But again, it's something that he decided, hey, I think we can make a big difference. So the ocean cleanup is, their goal is to get rid of 90% of the floating plastic by 2040. And I mean, that's billions of tons of plastic that in many cases have been out there since the 1970s. Certainly with the Great Pacific Ocean patch, that's the case. And so what we need to do is scale it up. Now, he's been there for a while, and I was quite impressed the fact that I went back 4 years later to see what was happening with him. And now he's saying, okay, we're going to get rid of that legacy plastic, but you know what? Most of the plastic is coming out of, I think it's the top 1,000 rivers in the world, dumping more plastic into the ocean every day. We got to solve that problem, so we went after that. But here's the quote that I think is really important, is when, let me go back to that. Here's the quote that I think is really important, is when people say something is impossible, that statement in itself should be enough motivation. And I think the nice thing about that is if you look back through history of all the great inventors that went after, some of the technologies that change our everyday lives, it all starts there. This is an impossible problem, but I want to solve it. So what I want to do is I'm going to take a risk, and I'm going to play a video. I found this video that I thought was really good. It's 2 minutes, so you don't have to come after me with the bell. And hopefully the audio folks back there were tweaking the audio to make sure it sounds all right. When you watch a film like that, they used a lot of AI tools actually to help them map and scale and so forth. So a lot of high technology involved in that. It's not just getting a big net out there and just scooping up the plastic out of the oceans, but they used a lot of that But also, you see a young engineering student that decided, hey, this is what I want to do, and this is my passion. And we heard about that passion this morning, right? And I know that in the student judging I was doing today, I saw a lot of great projects. Students very passionate about the projects they chose. So that's our challenge. That's our goal, is to get the students involved. Now, we all know about the Sustainable Development Goals, and I have to tell you, I was extremely pleased during our judging this morning that all the projects were all focused on, addressing some of the SDGs, so much so that they even went out and mentioned which ones in particular that they were addressing. So again, this is where I think we can really make a difference in inspiring our students. Now, the curiosity part I think is critical, because again, one of the things we don't want to do is we just don't want to get our students to be able to memorize formulas and crank out solutions to equations and so forth, but we want to take them to that next level. And you heard Krishna talking about the hierarchy of learning and all that sort of thing, and it really kind of culminates in this idea of, can we get our students to be curious, because ultimately that's what's going to make a difference. Now, we know about Albert Einstein, and he's very humble, but he was very curious for certain, and but he did have a warning, right, about formal education. Does that force curiosity out of individuals, because they're so focused on what they've learned, and that's the only way to solve a problem? So we have to figure out a way to educate them with all the fundamentals that'll give them the tools to be successful, but at the same time not discourage them from being curious and to push on assumptions that we all take for granted. So there are ways we can do this, right? I mean, one of the ways, let me see how this is going to go, okay, is recognize curiosity in the classroom, value it, reward it, whether it's through recognition or through some type of additional grading system or whatnot. I think that's important. Ask students to ask good questions, and you can get students to ask good questions, right? It's not just a matter of, I don't understand this, but what aspect of it don't you understand? And this is kind of where it comes back to the assessment of student learning, is what aspect of the learning process are they not getting, right? And so asking your students to be inquisitive and ask questions, even if you think that, they might be ridiculous questions, ask them anyway. Confusion is growth, right? And Bill talked a little bit about that today, about the faculty doesn't know everything, students don't know everything. So together we're going to make that journey. So we have to acknowledge the fact that confusion helps us to a large degree, okay? Tinkering, of course, is critically important, so getting students to be comfortable with doing that. There's so much being done now in software. That's a great way to obviously do things, but certainly having some experience in the laboratory and just playing with things is good. Connecting learning to current events, of course, that is all about what we're talking about here, really. And be curious yourself. I mean, there's no reason you can't, as an example, in the classroom say, hey, what about this? Or did you think about that? Because students take their cue from all of you. And I think, giving examples of asking curious questions is important. So kind of wrapping up here, I think together with all of this, it's this next generation that we're going to depend on to really save ourselves, and we have to give them every tool available. Certainly artificial intelligence will be part of that, but also the human tools of curiosity, and again, everything that you do to prepare them fundamentally. So with that, I want to
Thank you very much, sir, for enlightening us on the importance of empowering tomorrow's innovators, cultivating curiosity and resilience in Gen AI era. Thank you, everyone.